Good day everyone, our topic for today is Anova and Manova. Multivariate analysis of variance, Manova, is an extension of analysis variance, Anova, to accumulate more than one dependent variable. The terms univariate and multivariate, when used in Anova and Manova, refer to the use of single dependent variables, respectively. Though both Anova and Manova provide the tools necessary to judge the observed effects, Manova has a role in non-experimental designs where groups of interest are defined and the differences on any number of metric variables are assessed for statistical significance. The following are the multivariate procedures for assessing group differences. The first column shows the number of groups on an independent variable, the second, number of dependent variables, and the last one, types of tests. When there are two groups on an independent variable and the number of dependent variable is 1 or univariate, the type of test to be used is t-test. But when the dependent variables has 2 or more multivariate, the type of test to be used is a Telling's t-squared. When there are 2 or more number of groups on independent variable and are generalized, and the number of dependent variables 1 or univariate, the type of test to be used is Anova. But when the dependent variables 2 or more multivariate, the type of test to be used is Manova. Advantages of a multivariate approach to significance testing compared to the more traditional univariate approaches. 1. It can assess group differences across multiple metric dependent variables simultaneously. 2. The dependent variable variate can be combined in a linear combination as what is seen in multiple regression and discriminant analysis. Thus, it becomes of more interest for researchers. 3. It avoids the inflation of the overall type 1 error rate due to multiple t-tests or univariate testing of hypotheses. 4. The variate in a multivariate analysis of variance can optimally combine the multiple dependent measures in a single value that maximizes the difference across groups. The assumption for the use of Manova must be met if a researcher uses it as follows. Number 1, observations must be independent. 2, variance, covariance matrices must be equal for all treatment groups. 3. The set of dependent variables must follow a multivariate normal distribution. Stages in the process of performing a multivariate analysis of variance. Stage 1, research problem. Stage 2, research design issues. The third stage is number of independent variables or assumptions. Stage 4, estimating significance of group differences. Stage 5, interpreting the effects of variables or identifying the differences between groups. And the last stage is validating the results. The questions allowed when using Manova are as follows. Number 1, multiple univariate questions. It is where a researcher identifies a number of separate dependent variables that are to be analyzed separately but needs some control over the experiment-wide error rate. Number 2, structured multivariate questions. It is where a researcher gathers 2 or more dependent measures that have a specific relationships among them. Example, repeated measures where multiple responses are gathered from each subject. Number 3, intrinsically multivariate questions. It involves a set of dependent measures in which the principal concern is how they differ as a whole across the group. For example, testing of multiple measures of response that should be consistent, such as attitudes, preference, and intention to purchase, all of which relate to differing advertising campaigns. Issues in the research design concerning the sample sizes needed. The following are the basic issues. Number 1, the sample in each cell or group must be greater than the number of dependent variables. Number 2, the recommended Minimum cell size is 20 observations. Number 3, as the number of dependent variable increases, the sample size required to maintain statistical power increases as well. A researcher reconsiders the factorial design, an analysis with two or more treatments, in order to determine the impact of multiple independent variables in forming the groups with significant group differences. A blocking factor is the most direct way to account for the effects of the independent variables separately. In taking into account the number of treatments, the following are related. Number 1, number of cells formed. The overall sample is equal to the number of samples in a cell divided by a certain percent of the population. Number 2, creation of interaction effects. Interaction in statistics refers to the representation of the joint effect of two or more treatments. Another issue in the research design stage is the inclusion of metric variables as covariates, which can extract extraneous influences for the dependent variable, thus increasing the within-group variance. In making a research design using Manova, one can use repeated measures model, which accounts for the dependence and still ascertains whether any differences accrued across individuals for the set of dependent variables. Example, a researcher wants to assess improvement on test scores over the semester. In this case, he or she may expect to see different trends for those with low versus high initial scores, and his or her interest is on how much each person changes, not necessarily the changes in group means over the semester. Anova and Manova assumptions. As discussed, 3 assumptions must be met for the multivariate test procedures of Manova to be valid. The first one, independence of observation. Number 2, equality of variance, covariance, matrices. And 3, the set of dependent variables must follow a multivariate normal distribution. Under the third stage, the researcher also considers several issues that influence the possible effects, such as linearity and multicollinearity of the variate of dependent variables. To meet the independence assumption, the researcher considers the following: time-ordered effects, gathering information in group setting, the possibility of high correlation between or among groups' responses, employing a blocking factor or some form of covariate analysis to account for the dependence, and when the dependence is suspected, the researcher should use a stricter level of significance, 0.01 or even lower. In achieving the equality of variance covariance matrices, the following are taken into account. A. The test of equality of covariance matrices is typically known as box M test. Second one, by considering the sensitivity of the box M test, the researcher can set a conservative level of significant differences. For example, 0.01 instead of 0.05, even in simple research designs. And last, the inequality of variances allows the researcher to make adjustments for their effects in the interpretation of the significance levels of both man and interaction effects. Normality in Manova has these assumptions. 1. All the variables are multivariate normal. 2. The joint effect of two variables are normally distributed. And last, any departures or deviations from multivariate normality are usually inconsequential. In addition, Manova and Anova are especially sensitive to outliers, as well as on the type 1 error. Hence, the researcher is strongly encouraged first to examine the data from the outliers and eliminate them from the analysis. Estimation of the Manova model and assessing overall fit. In calculating the appropriate test statistics for Anova and Manova, the general linear model or GLM is used. In establishing the criteria for significance testing, the most widely used measures are: number 1, race greatest characteristic root or GCR, most appropriate when the dependent variable are strongly interrelated on a single dimension. Number 2, Wilks lambda examines whether groups are somehow different without being concerned with whether they differ on at least one linear combination of the dependent variable. And the third one, Pillai's criterion and Hotelling's t-squared, considered all the characteristic roots can be approximated by an F statistic. The four statistical criteria have the impacts on statistical power based on three considerations. 1. Alpha level. As a rule, the researcher should try to maintain an acceptable alpha level in the power in the range of 0.8. It is assumed the researcher may increase the overall alpha level to allow a more reasonable alpha level for the separate tests. Second, the effect size. Notably, the effect size has a direct impact on the power of the statistical test. It is a measure of group differences, typically expressed as the differences in group mean divided by their standard deviation. Number 3, sample size. As this is the most controllable by the researcher, the number of sample size taken is inversely related to the sampling error component. Interpretation of Manova results. In this stage, the three steps to interpret the Manova results are: 1. Interpret the effects of covariates if employed. 2. Assess which dependent variable or variables exhibited differences across the groups of each treatment. Number 3. Identify whether the groups differ on a single dependent variable or the entire dependent variable. Graphically, the interpretations of the Manova results also include the types of interaction, which represent the differences between group means when grouped by levels of another treatment variable. Number 1, no interaction. The effects of each treatment are constant of each level and all the lines are roughly parallel. Or number 2, ordinal interaction. The effects of each treatment are not constant at each level and the lines represented are not parallel. Number 3, disordinate interaction. Same of the lines treatment effects are parallel but others are not, causing variations in their directions. This kind of interaction interferes with the interpretations of main effects. In this stage, two types of multi-group tests are conducted, namely: 1. Post hoc test. Test of the dependent variables between all possible pairs of root differences that are tested after the data patterns are established. Number 2. A priori test. Test planned from a theoretical or practical decision-making viewpoint prior to looking of the data. Validation of the Manova results. The primary means of validating Manova results is replication, defined as repeated administration of an experiment with the intent of validating the results in another sample of respondents. In many instances, demographic characteristics such as age, gender, income, and other like are used as treatments.